we're not here. So we've got man is walking away from a lamppost with a light source 6 meters above the ground. Man's 2 meters tall. How far from the lamppost is the man when his shadow is 5, we'll say, meters long as opposed to feet? That would make it a lot more difficult if we were converting. We just won't do that. So you're really smart and you've done this problem before. So tell me how to set it up. Draw a lamppost and make a triangle. Okay, I like where you're going here. It's got a lamppost, beam of light, 6 meters. Now draw the man. He's 2 meters tall. Somebody said something about a triangle. What else? Shadow, 5 meters. What am I trying to find? Thank you for answering. Unfortunately, it's incorrect. Try again. Yeah. We'll call D for distance. So the question is, how far is he from the lamp post? Notice that I do not have just one triangle, but I have two triangles, correct? I have a blue triangle and a black triangle. Fair enough? So these two triangles are similar. Why are they similar? What do you have to have in geometry in order to have similar triangles? Same angles. How can we verify that these angles are all the same? How can you know that without just simply making an assumption? Okay, you do have a right triangle. Not all right triangles are the same, though. So you got this angle is the same, and then obviously they share that angle, right? If two angles are the same, does the third have to be the same? Yeah, so by angle, 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 they are similar, which means that their sides are proportional. Look at all the theory we've developed together. So now we can accomplish this problem. Proportional means we can take the height divided by the length. I'll say y over x. So I just write down a ratio so I can help myself make sure I organize this. So what's the height of the man? 2. And what's the length of his shadow? 5 equals, what's the height of the lamppost? 6. And that'll be over D plus 5. That distance plus 5 as a whole. Now, if you call the entire distance D, then you would just subtract 5 at the end, right? So I will cross multiply. I get 2D plus 10 is equal to 30, or 2D is equal to 20, so D is equal to 10. So, no big deal, right? D represents this distance from the light post. You've seen that type of a problem before, right? I'm confident that if you had to set it up, you could set it up and solve it. Well, what about a problem that you haven't seen set up before that involves triangles? Could you do that? Two flag. If I help you. Well, today on your assignment, you will see that every problem has been set up for you except for problem number 14. And the goal of a mature mathematician is that you would be able to eventually figure out a problem without having it fully set up for you ahead of time, right? And so that's what you want to strive to do. So when I encountered this problem a few years ago, I solved it 3 different ways. And in 2 ways I solved it, I don't think that you really would have understood very well. And so we're going to go to a third approach, which I think is a very powerful approach in mathematics. And I think it's one you probably haven't seen before. So we have 2 flagpoles of heights 9 and 13. I was an art major. Okay, here we go. All right, enough of the fun. This one's 9 feet tall and this one's 13 feet tall. It says that ropes are connected from the top of the poles to the other's bases. Now I know, and I wrote that, I didn't write it very well, but on your assignment should be grammatically written much better. And so as we connect it, for some reason there's there's ropes attached from the top to the bottoms. The question is, how far from the ground do the ropes cross? Meaning, what is this distance right here, or this height? We just did similar triangles before, right? It's possible we could say that those two triangles are similar, but it's tough to guarantee that they're for sure similar. I guess if you look at parallel lines and alternate interior angles, I guess we can make that argument that they are similar. But we really don't know any distances or lengths on the actual triangles other than the 9 and the 13. And so I'm going to ditch the similar triangle approach. I've solved it using a similar triangle approach. It wasn't very helpful. But instead, what I like to do is show you something new. Yeah. The opposite angle? Yes, without a doubt. And so we can show that these two triangles are in fact similar, but I'm not sure that that's the best way to solve the problem. So what I did is when I solved this problem a few years ago, I gave it to three other people who were math majors, and they all ended up solving it eventually the same way that I did. And so what I want to tell you to do is I'm going to call that line 1, and I'm going to call this line 2. Two lines intersect at a coordinate, right? Wouldn't you agree that the y value of that intersection would be the height at which they are above the ground? And so if I can simply find the intersection of the two lines, I will then know how high above the ground they intersect. Now you say, well, that's different. We know how to find intersection of two lines if we're given the equations. And generally you have like an x and y axis. And I say, well, what's keeping us from making an x and y axis? Come on, just draw it on there. All of a sudden now I got a coordinate plane. Thank you for your enthusiasm. I agree. Sometimes people start swearing or throwing things at me, so good for you. So I'll start out. I just need to start identifying points. Anybody tell me that location of that point, its coordinate? Very good, 0, 9. How about this point here? We're flying. Actually, there's a certain x value here, right? But we don't really know how far over they are. They don't tell us how far apart they're separated, do they? So I'm going to call that d just for the distance that they are apart. And then the y value would be 0. And then we could write a nice expression for that point up there, which would be d13. So we have line 1 and we have line 2. For line 1, I'm going to write an equation. I'm going to find slope, and I'll find the y-intercept. Look at line 1. I go from 0, 0 to 13, or to d13. What is my rise to get from 0, 0? It's 13 is my rise. What is my run? D. What is the y-intercept? 0. Line 2. Line 2. I look at the slope. What is the rise of line 2? close, negative 9. What is the run? D. And how about the y-intercept? 9. Isn't 9 in German? Is that no? It doesn't mean no. 9. 9. All right. Okay. So now I'm gonna write equations. Y is equal to m 13 over d times x plus b, and b in this situation is 0. The second part, y is equal to negative 9 over d times x plus 9. Are you okay with that? We wrote, what's bothering you right now? What's bothering you? You don't like the D, do you? Just admit it. I hate the D. We don't like the D, do we? Okay? And if you didn't like it, I'll tell you what, you could just plug in any number there. Let's say you plugged in 5, and you could solve the problem. It'll work out for you. But we're going to show you that it technically doesn't matter how far apart they are. The height will always remain the same. Okay? So now we get to the point where you guys, the algebra really comes in. So you tell me I have two lines, they intersect. How do I solve for the intersection between two lines? They're both equal to y, so they're both equal to each other. I'm going to do something that sometimes makes people upset, but I'm going to put x in the numerator because x is x over 1, so it belongs in the numerator. I do have some like terms here, don't I? So I'll add the 9x over d to the other side. I get 22x over d is equal to 9. 9. Now what? Times by d, 22x is equal to 9d. Now, divide by 22. And so we found the x value. The x value is 9 times whatever distance they're separated by, divided by 22. But what you want to know is just the height, right? No big deal. How do you figure out the y coordinate once you know the x coordinate? Y is equal to 13 over d times 9d divided by 22. And now the aha moment should happen. What do you notice? The d's cancel. That shows that the distance that they are apart really plays no role in this situation. We end up with y is equal to 13 times 9 is 117 over 22. Somebody take that and divide that in your calculator for me so we can get a decimal approximation. So what this shows us is if they're 30 feet apart, then it's 5.32 feet above the ground that they cross. If they're 1,000 feet apart, then it's 5.32 feet above the ground that they're apart. But the cool part of this is that, how are you going to solve it? Well, let's create a coordinate plane, and let's solve it using this way. Now you're like, I'd like to see another way. Go ahead. Take it home tonight and see if you can solve that, come up with a 5.32, but don't do it using the coordinate plane. If you come up with a solution and it's 5.32, I'd love to show it and let the rest of the class see it. But the point is that A, is this a little bit involved? And every year people have the same response. They're like, I could never do that on my own. You know what's going to happen? You're going to do it on your assignment. You're going to get it right. Then you're going to do it on the study guide. You're going to get it right. And you're going to say, you know what? I used to hate this problem. I actually like it now. And that's good because, yeah, that took us 10 minutes. But trust me, we're going to get to problems that take us longer than 10 minutes. You guys need to be able to sustain that because you're sharp kids. Flip it over. Let's do one that you have done before, okay? Let's talk about investment. Tom has $9,600 to invest. He invests a portion of it at a rate of 4% a year. The rest he invests into a riskier market earns him 10% a year. If his total earnings of the interest were $528, how much did he invest in each place? Okay? So, we've got investments, and we've got two numbers that are really driving this problem. Number one, we have 9,600, which is the total amount of his investment. How many places is he investing his money into? 2. So we have place A and we have place B. Somebody give me an equation that involves A, B, and 9,600. Okay, excellent. Except you wrote the equation for the 528. You use 0.404, right? 0.04 and 0.1 have to do with the 528. Few people had it. A plus B is equal to 9,600. The amount you invested. Sure, yep, it's a free country. America, make a choice. USA, USA. All right, so you got A plus B is 9,600. But we have another number that's driving this equation, which is 528. And that refers to the investment, right? The interest. Well, if I invest $100 into A, how much do I actually make in interest? 4%, which is $4. If I invest $200 into A, I get $8. You get whatever 0.04 times A is. So we're going to go to Rhiannon's equation here, and this represents the amount of money we get out of our investment, and it has to add a 528. So what I need to do now is I need 2 unknowns, A and B, which requires 2 equations. 2 unknowns, 2 equations. 3 unknowns, 3 equations, so on and so forth. So I got these 2 equations. How can you solve it? Give me an idea. Elimination, good. Okay, so what should we do instead? Substitution. So I'll say that B is equal to 9,600 minus A. So I've solved for a variable. I may now use my substitution principle. So 0.04A plus 0.1 times 9,600 minus A is equal to 528. Sweet. 0.04A plus 960 minus 0.1A is equal to 528. Negative 0.06A plus 960 is equal to 528. Okay, what is 528 minus 960? Yeah. Very good, negative 432. Divide both sides by negative 0.06. Okay, 0.04A and negative 0.1A. We take 0.04 plus negative 0.1. That makes negative 0.06. All right? Sorry. Okay, we'll try again. So 0.04 and negative 0.1, those are like terms. So 0.04 plus negative 0.1, I get negative 0.06. Right? Okay with that? Yep. So it'll be the same as 0.10 minus 0.06. Okay, we got it? Okay. All right, so then I'm here. I'm to negative 0.06A is equal to negative 432. Negative 432 divided by Negative 0.06. I get 7,200. So negative $7,200 at what percent? 4%. So then how much invested into B? How'd you get that? Yep, put it back in the equation. There we have it. Let's do one more today. You're sitting in chemistry class. Oh, God. What do you guys like? Okay, we're in show and tell right now. Okay, we're in chemistry class. You got beaker A and you got beaker B. There's a certain amount of acid in each beaker, but it's also watered down with another solution. Okay, beaker A, 60% acid. Beaker B, 30%. We want a 50% mixture. Is it possible to create a 50% from a 60 and a 30? Could we create 100% from a 60 and a 30? Not just by mixing them together. We'd have to somehow remove the acid, right? That would be like, tough. So anyway, we want to do this. So we really have two equations again. We have our total amount. What is our total amount of solution that we're going to have? We're at 300 milliliters. Somebody give me an equation involves A and B and 300. The amount of solution from beaker A plus the amount of solution from beaker B must total 300. I have something else that's going to drive my equation. The amount of acid. This is the number one most common mistake on this problem. We put 0.5. It is not 0.5. Who can tell me what I should be putting instead of 0.5? 150. Why? Exactly. Look at your previous example, folks. Okay, focus right here. Don't be confused. This refers to amount of money, right? This also refers to an amount of money. We didn't put a percent here, we put an amount. Well, here we have the total amount of solution. And in that solution, how many milliliters of acid should there be? There should be 150. Okay? So 150 milliliters should be acid. So what percent will come out of A? Right, so let's say you put in, thank you. Let's say you put in 100 milliliters from A. Well, you'll get 60 milliliters of acid then. We want a total of 150 plus 0.3 from B. That will equal the 150 milliliters that we need. See that possible mistake? So now I'm going to take somebody's suggestion, and instead of using substitution at this point, I will show you elimination. If I want to eliminate, what should I multiply the top equation through by? Sure, you could choose negative 0.3 or you could choose negative 0.6. Doesn't matter. The one I heard was negative 0.3, so I'll do that. When I do that, I get negative 0.3a minus 0.3b is equal to, looks like negative 90. So now that top equation really doesn't need to be used anymore. I've changed it with the second equation. I will add those together. And I get 0.3a is equal to 60. How do I get rid of the 0.3? Divide. What do I get? $200 milliliters of what percent? So then B is equal to 100 milliliters of 30%. Make sure you're answering the question so we know exactly what you're getting. Okay. All right, so if I could show you in terms of requirements, number one, you've seen mixture problems before. And the fact is that on your test, you're going to have to do a consecutive numbers problem, an area and shape, similar triangles, mixture of money, distance and rate and time. Tomorrow we'll do distance, rate, and time and work. But today, 1 through 13 are all problems that have been modeled for you. I showed you today one that you didn't have modeled for you before. It was the flagpole problem, and I showed you what my aha moment was. I'm going to allow you to try to arrive at your aha moment for 14. Don't worry if you don't come up with it. But if you give up after 2 minutes, you do not have the persistence or the effort that is required to be a great mathematician. If you're spending more than 2 hours, you need to stop, okay? And if you're wondering when that aha moment comes, it comes when your subconscious is at rest. And I kid you not, when I'm doing my math work, like graduate work, I keep a notebook beside my bed. And when I'm ready to fall asleep, it's happened to me at least a dozen times to where I go over and I write down the solution to the proof that I've been pondering for a while. You need to put your mind at rest. It's also happened to me where I'm working on something for class. I'm like, well, what if we do this? Well, that's a really tough problem. I'll have to think on that for a while. I get up the next morning, I'm shaving, I'm like, oh, I know how to do it now. So you got to be restful. If you are anxious and overworked, it ain't going to happen, folks. But if you want to try to be a pure mathematician, solve 14, get after it. Good luck. See what you're made of.